Okay, welcome everybody, and thank you very much for agreeing to come and letting me here entertain you, try to teach you a little bit, but mostly, hopefully, you will have some laughs and a good time. Speaking of, any of you having good time, having fun? Yeah. Hey, that didn't sound too much. I think we need more coffee there. I was telling him that has to be stronger here, fuerte, but okay. Hello, everyone. I am Leandro Melendez, and as Tariq very well said, I'm gonna be talking about you performance, this hidden, misunderstood, weird, or perennial art of testing. And well, it is an evolution. It's something that has been changing. I don't think that we can feel that special, because probably everyone here will agree everything in QA is changing, has to be evolving, we have to keep learning. But today I come to show you and talk to you a little bit of how is this evolution happening. But, oh, come on. For the ones that do not know me, probably like Tariq, you only knew me as Señor Performo, but I am Leandro Melendez. I am a DevRel, advocate, evangelist, whatever you want to call it, with Grafana K6. I try to spread the word of performance all over the world. As well, as Tariq mentioned, I started it all with a blog with this not so secret identity of Señor Performo, where I started to try to explain performance testing topics that often, and true story, my first analogies and examples trying to make it fun and engaging was an example or an analogy with training dogs. Anyone here familiar with the dog whisperer, Cesar Millan? Raise your hands. I see some hands. Okay. So you were familiar, start doing that with the puppies. But it all came up to me because when I was explaining to some C-level managers and people as a consultant, hey, I come here and I'm going to do this performance thing. And I started to explain all those complicated terms like ramp up, throughput, and many other fancy words that we use. I kept seeing the C-level managers and all them twisting, what? Have you seen that expression when you are like, and they don't understand it? What are you? Some others were just falling asleep. So I was like, how can I keep it entertaining? And that's how the blog started. I wanted to tell stories, to do silly examples, and some of those things you are about to experience and observe. But after a little while, things started evolving and I got invited to, I think I need to change this in order, say YouTube first. But first the podcast happened. I was invited to PerfBytes to start generating some content for the people that couldn't understand English or wanted to get it in Spanish. So I went for PerfBytes Español, part of the PerfBytes family of podcasts, the one that Tariq was mentioning that hopefully was well explained and with good Spanish. I use lots of Mexican slang on that podcast. Some friends from South America have told me like, what is that? Like, oh, I don't think I should explain that online. So, and after that, I got curious. I was like, hey, why don't we start a YouTube channel where like, what do I do? English, Spanish, mix them all. So I have two channels, one in English, one in Spanish. The Spanish one is Señor Performo in YouTube, just Señor Performo. And the one that ends in ENG is the English channel. On those, you will find some other silly examples, some of the interviews that you have been seeing, and many other things that I haven't had the cannons that I wish I kept, but I still put stuff up there. And yeah, as well, I do public speaking. You see me up here. I like to go and entertain people and be dancing some salsa up here. And last but not least, a book. I finally, some people got some situations going on during the pandemic, during the lockdowns. And on my side, I managed to finish my book and publish it, and it's ready in Amazon. If any of you are curious of the ways of pulling off a traditional load testing project, it's the Hitchhiking Guide to Load Testing Projects. I should have shortened it up, but kind of doing a lot of example references to the Hitchhiking Guide to the universe, and many other silly things, chanclas, tortillas, and lots of Mexican stuff. Last but not least, you may not have noticed, but I'm Mexican. So, but everything good, and I'm here legally, no problem, no bad hombre, good hombre, I hope. Really, really hope that you keep thinking that. So thank you all again for being here. I would like to build you an altar, and I'm super happy to be here on the 40th, like a landline? No, milestone. A milestone for this conference. It's such a honor, and this is my first time around, and I'm really thrilled and happy to be here. And thank you all again for being here. So finally, let's get going. I have an interesting menu for you today. We are going to start talking about what's performance testing, having an idea, because many, believe it or not, have no idea. Even some professionals in the field that I have worked with are not 100% there on what exactly is performance testing. Next, we're going to go through the challenges that these modern times are presenting to performance engineers, or performance assurance, like we have quality assurance because we're trying to do quality, which involves testing. Performance assurance, we are trying that our systems are performant, assuring performance. And we're going to close this meal with ways to evolve. Some recommendations, some things that we should do in these modern, agile, continuous, cloudy days on how to implement some of these recommendations, and so that you understand what is the deal, what is the change, and how to better make front of it. So starting off, what is this performance thing that I have been talking about? And probably some of you may be like, why are you doing a big deal out of it? I know it's like when you would do many scripts and say, I'm the system, right? Wrong. Not necessarily. A dictionary definition of each one of the components of the term performance testing. Testing, I'm sure here I don't have to come and define, but a quick and short definition is to verify, validate, to be aware of, know about this information, observe it, taste it. I mean, that's a testing session as well. So that's testing. Performance on itself refers to the speed and the efficiency of something. Those two elements do performance. The definition, we're talking about software, so it's referring to software. So in short, performance testing is the validation, verification, observation, knowing how fast and efficient is our software. That's it. Have you heard slamming or multiple users on that definition? No. That's kind of, but it's not in the definition. So we have three main components on that. What we are going to be verifying. As I said, the speed, how fast is the software. We will measure it usually in time. Then we have the efficiency, where we are going to measure or check what is the impact of the action we do on the software. What else happens? How much RAM, resources, hard drive, all those good things that our machines need. And last is the key component, the situation. When do we want to know the performance? Because everyone like, yeah, load, hit it, put a bunch of users and we'll figure out what is the performance of everything. It doesn't work that way. I give an example at times, would be like, you just assembled a Formula One car and let's figure out if all the pieces work well by racing it. Good luck. And there are many things with this example that I'm going to come back here and there to picture what is the situation that I'm saying. So these situations can be many. Just one tire with the car, spin it. Can be no users on the system. can be one user, 5 only, for long periods of time, short periods of time, all of them just hitting the tire instead of putting gas on it. So multiple different things. So for this, we have the Triforce, I like to call it, self-defense, probably here will know the reference. The Triforce of components for performance testing. How fast the software is it? How efficient is it? Under what circumstance? And again, these circumstances are not only or just load testing like that. Here, the little perrito, little doggy is telling you, you look at those sad Chihuahua eyes. He's super sad thinking that you think it's only load testing. It can be, as I said, one user, none. This is also very important. Many do not pay attention to that. Do you want to know the fuel efficiency of your car? You need a baseline or the basal fuel efficiency of your car. Turn on your Hummer and let me know how much gas is it burning just by being turned on. And that's a valid performance test to know how much gas is it consuming. The same with IT systems. Turn on the system and see how much RAM is it consuming just as it is. So you will know what is the extra when there's activity. So there are many, many valid performance tests. One user, some mixes here and there. And not only that, there are performance testing is a huge umbrella of possible things that we can do to assure that we have great performance. But why should we care? Well, money, dough, moolah, dinero. That's eventually what it translates into if we don't pay attention to. Yes, there can be lots of sweat, tears, blood, sacrifices, as you'll see in a moment, if we don't pay attention to that. But in the business environment, it all translates into money. Why? Well, we want to pay attention to performance to have our users being internal, being external, at the maximum, being super efficient, super happy, being able to buy, to get our services, whatever they need to do in our system, keep scrolling, watching seasons of whatever we are watching, hitting likes, doing all that good stuff. What would it be if you, I have to, we wouldn't be that addicted to that software. In essence, we would like to be like that on the applications that we develop. And what is the problem with this? First, if our software is external toward customers, we will lose sales, we will lose revenue, there won't be activities, we won't be able to sell services, we won't be able to have them hooked into our systems. And many say like, yeah, but my software is internal, I don't care. They let the employees deal with it. Well, you invested on that software, supposedly, to increase their efficiency. If they are not being able to be more efficient, you're wasting that investment. How can you justify that to management? And on top of that, I mean, sad employees, like the psychological repercussions, all those tears, and that's where I was saying, probably even blood and situations that you don't want to deal with. And also with external customers, you may lose face value, reputation that's super, hyper expensive to recover, maybe even impossible, not even with MasterCard. So, and last as well, the availability. There's another, we have like a recurrent joke at the PerfBytes podcast of a store that boomed and we're so excited because, oh my God, we launched the product and the site is down. Can you believe it? It's awesome. But you're not selling anything. Why are you so excited? Like, doesn't connect. So you gotta be careful that your system is up continuously, constantly, at all time, and that you can do business with it. And all that translates into money. Again, as I said, lost productivity, lost money. Lost sales, lost money. And having to fix these type of issues will cost you money. We all know the rule. Further in the left, that you detect an issue, you solve it, you fix it, it will be less expensive, time consuming, all those good things. If it reaches production, probably it will be catastrophic. I know of very good examples, which the organization is not there anymore, just because they didn't pay attention to this. So we have modern goals, like continuously probably that's not the best example here because we like to continuously be powering lime in our tacos. Probably it's because we like to put lime on everything. But so the goals in this modernity for us is to assure that our performance has great response times. That is snappy, that we click and we are not there waiting, the spinning wheel of that. That it is also efficient and stable. What does this mean? If it's efficient, it won't require many resources. It won't hog the resources, and it won't die if we have too many users or just a little bit of users if it's not performing and it requires a lot of resources. True story, I was in a project where they had like an LPAR, several CPUs, gigs and gigs of RAM when it was like a big deal, have multiple gigs of RAM, like hundreds and thousands of gigs of RAM. Not thousands probably, I'm exaggerating a bit, but it was huge. It was running an SAP system, very poorly done, programmed, lots of Z transactions. If anyone has experience with those things, I could kill that with 10 users. Big machine just because it was not efficient. That's why it is so important, because you just start doing some transactions and the system can go down. And this is important to continuously assure that we have this great performance in all situations. Again, when I told you, when there are no users, because we want to be able to leave our fridge on without seeing the power bill going crazy. That's important, no users. It's so many organizations that it turns off automatically. I'm giving examples of cloud pods that can be turned off efficiently and release resources, memory management, all those things are super important. That when no users, when one user arrives, it's snappy, it comes back, we suddenly have the container again, all those good things continuously, like the lime that keeps falling in our good taco. But there's a challenge with that. Now, we have big problems, burning Tabasco problems right now, because the most organizations, most engineers are trying to do performance in the old ways, where we were truly, we still are a little bit obsessed with load. As I mentioned, load testing, slam them, automate, lots of scripts, 1,000 users. How many users can my system handle? And I mean, the systems nowadays are like spread all over the world, multiple microservices. How do you even measure that? When it was a single monolith, well, kind of made sense, but now it's tough to measure that way. And speaking of modern, now we have continuous projects that we are releasing, hopefully at least once a sprint, into production, because if you're not releasing into production, you may not be that continuous nor agile. I heard a few laughs. I hope no one here is worried, like, I'm not that one. But that's key. If you're not releasing into production, at least once a sprint, you may not be that agile. But what happened before? We had those waterfall things that happened once, twice a year. And performance tests, again, just load testing happened just before we did that big bang, huge release, big set of new requirements, upgrading. And that is not possible anymore with this continuous mindset. The way in which we automated, we had several steps on our automations. Step 1, go to the login page. Step 2, login. Step 3, click this on the menu. I hope I won't fall down here. Let's go back to safety. We had to go through each one of those steps, and we were, frankly, just interested in triggering the save button that was at the very end of that set of steps that we had lined up. It was the way to do things before because we had the monolith and everything together. There was no other way around to go straight ahead. I usually give the example of a multi-course meal where we mostly are interested in dessert, right? That's why we want to go and test truly. And my mom was like, you have to eat everything before you get to the dessert. Okay, we had to go through each step. Now with microservices, it's like a food court. Like, yeah, I can go and get like vegetables or a salad and something. but I can go straight to Dairy Queen and get my blizzard, right? We really like to go straight and start to stress those parts. But another problem is that those automations were mostly done on the front end. We would bring a browser, again, record step 1, record step 2, and all of those steps in a browser, because there was no other way. And we had lots of communication going through that browser, that protocol. We had to decipher, reverse engineer. We had no access to the developers. It was very, very spicy, like Tabasco. The other thing is that we often needed frozen environments because we are measuring how this system is going to react to this big release that we are going to do. But now we are doing that again, hopefully, every 2 weeks. And on those days, it was like every 6 months. Okay, you can freeze the environment. Everything can be like no one moves until the almighty performance engineer comes here, executes, and okay, it's safe. The results were valid. But now, every time that you insert a new change, those results are not valid. That's not that efficient anymore. And another one, the testers were the only ones that could test and automate, were like the heroes of the story, the only one that could lift the sword from the stone and conquer and slash the dragon. And they're the only ones. They became, ironically, we were fighting bottlenecks, but they became the bottleneck. That was a big problem. Everyone had to wait. No one else could access the tool. You don't have a license. You are not registered in the portal. Lots of problems. And this generated also huge scenarios where we did lots and lots of users trying to bring down the system to its knees, and lots of complex pieces with all the little steps that we were doing in different directions, because in one we wanted Dairy Queen, and in the other one probably we wanted black waffles or something else. And we had to kind of balance and do big, a friend of mine told me to short it in an acronym, BALT test, B-A-L-T, big ass load tests, which that was the obsession, BALT performance tests. And because of those, that large set of steps that I'm describing, all those scenarios, the executions were really long to prepare. Those were heavy, slow tests. They took forever to be able to execute. And a best case scenario for me, a load test project would take 3 weeks. When the client was super efficient, we could just come, execute, and automate everything. And those were the well-behaved ones. There were some others that, imagine stopping your continuous process for 3 weeks, 4 weeks, 5 weeks, even more. And as well, the software that we used for that was heavy. I remember the very first installers for anyone here familiar with LoadRunner, lift your hand. Okay, some experiences. I remember the first installers were like 200-300 megabytes, then 700 megabytes, the whole CD, then gigabytes. I stopped counting when they were like 5 gigabytes, all the protocols inside, everything super heavy. We should stop trying to get those tools that do absolutely everything, because there's no silver bullet here. So, oh, I stepped ahead with the silver bullets. Another one is that in these huge softwares, when we were done, again, with the sword, the mythical hero, I'm the only one, and my tool is the only one that has the results, the data, and I'm the only one that can generate and give you the results. Every manager waiting like, are you done with the report? And in a moment, I became several times the bottleneck, because there was no other way, no one else that could give these results to management. And most of these things always happened, the executions, the automations, after development was done. Sad experience, at times I would find problems and I would say, hey, I need a developer to fix this. The software was already compiled, sealed, and no, we cannot get you a developer. Why not? Are they that busy? No, they are not even here anymore. They went back to India. Like that, not being stereotypical, but that was the example. That was happened. They went back to their country like, oh, damn, now what do I do? A software that we're supposed to release into production tomorrow. And everyone has been waiting for it for the last 6 months. So everything happening after development, no one monitored anything. I would come at the organization and ask him like, okay, you have this software that you are going to performance test. Okay, how is your utilization? How many times are people clicking on everything? And they're like, I don't know. Wait, what? That's what you come here for. Wait, what? That's not performance testing. No one had any idea, no monitoring, no instrumentation. It was actually difficult to do, and it was actually kind of heavy to insert in the system. And it's a big recommendation. We'll get into that, but it's like having instruments and all the measurements that you have in an airplane. Have you seen like all the dashboards and things that the pilots have? But if for some reason the airline decides that that's too heavy for the airplane because they cannot put enough people in it with all those instruments, lift your hand if you would get on that airplane, right? Yeah, this time I wasn't expecting any hands. Everything was a black box. Everything was like, the only way that I could know how the software was responding was to do an automation. And because those monoliths was complicated, it's different flavors, everything compiled into one. There were so many more issues that, as you can see, I'm already kind of pointing it in a negative tone, but yeah, it wasn't easy. But sadly, many people are still trying to do performance testing that way with all the advantages, all the evolutions, new technologies, new methodologies that we have right now. And that's silly. We have to change the perspective. We have to change the way in which we're doing things. As I keep telling another car example, I've seen people in organizations trying to do performance testing with their new Teslas, trying to put the gas pump, like finding places where should I put this, and just like, I'm gonna put it in the trunk, that's good. That feels like to me when I see people like, yeah, we should automate a lot and do these big load tests. Like, no. First of all, you need to start testing and automating just what is relevant in this sprint, because supposedly we are releasing little by little, right? We already have an MVP in production, right? We already know what's a performance in production, right? Right? Uh-oh, and no one is like nodding. We just have to test those tiny incremental releases that we are putting in production, not everything at once. Supposedly we already know how production is doing, right? And especially because all these little changes are continuously moving something in production. It's impossible that if we do a bolt, we put a tiny little thing, that bolt is not valid anymore. Those results, we need to see what changed. The focus now is on the change that continuously happens. We need to continuously be able, instead of doing those bolts and slamming the system, trying to bring it down, we need to continuously validate and verify what is the performance of our software. And all this has to happen before we even think of the creation of the software. And that's mind-blowing for many people. Like, wait, I haven't even coded the first line and you're talking about performance. What's wrong with you? No, what's wrong with you? Why do you want to create software without those airplane dashboards and things? You're already in the air and you don't even have like a meter that tells you, you don't even know how high you should go and you want to fly right away. When we are creating software, we should know the performance. We should automate and create whatever is relevant, tiny, easy. But not only that, we should be able to inherit that into production and know what the performance keeps being after our software reaches production. So there are so many things that we need to change the perspective into to enter into the modern performance world, into this modernity that we have nowadays. The first one, again, performance testing is not a synonym with load testing. If anything you get out of this, I want you to remember, performance testing is not equal to load testing. It's not the only thing in load testing that you should do in a performance test. You should do so many other things before you even dare to do a load test around performance. There are so many other pieces and things that you should keep in mind. Please, performance testing is not the same as load testing. To give you an example, Microsoft Word is the same as Microsoft Office, right? Kind of feels weird, maybe part of it. But if I tell you, like, you have to do everything Office with Word, I mean, I've seen people try. I mean, we all have, but most probably it's not the way, right? So that's the biggest thing that I want you to get out of here. Performance testing is not only load testing, and it's the last thing that you should be thinking about. So what is it then? First, observability. This to be able to see and know. I like as well, Lion-O, sight beyond sight, to be able to tell what is the deal with the performance of my solution without needing automations, without needing to run a vault, without needing to do all those things that we did in the old days. We achieve this through instrumentation, telemetry, with monitors, with synthetic automations. So with instrumentation and telemetry, we create our software. Picture this, software created that tells us its performance. Without automations, oh my God. What are we gonna do? We're gonna starve. And that's another key element. But the software should be created telling us what is its performance. And by the way, parts of what is its QA status, that's another one that we can achieve through instrumentation and telemetry. Monitoring, the APMs, which used to be application performance monitors, but now we are in modern days and they changed that last name into management. Because from those measurements in the monitoring, the system, the APMs can take decisions and trigger some other things. So it's a big complex set of things that we can do. And synthetics, that's as well very important, because when we have our software in production or when it's moving towards there, so anyone here, you get into a site, it's unresponsive, it's stupidly slow, what would you do? Close the window. Anyone? Oh yeah, the rage clicks, which actually makes things way worse. But all good. I mean, that's what most of us do if that happens. No one here thought of reaching out to support and telling them, right? And that's really important, because as ops, as SRE, if I don't know that the system went down, no one is gonna call me. Well, depending on the type of service, but most frequently, everyone said like, no, I will shut it off and like probably shake my fist very hard, and that's it. Synthetics are very important for us to know when those things happen. Not only when the system goes down or disappears, but when it starts to get slow or misaligned. And this is part of this constant and continuous observability. Another little element, this observability shouldn't be only in production. The APMs, the instrumentation, all these things should be in the developer's machine. We should be able to tell when the developer compiles and clicks run and is debugging, right away know that it's not performing. And everyone should be aware of this. Moving as we go through the pipeline, through staging, QA, pre-prod, whatever you want to call it, until it arrives into production, we should know it all the time. We need to become, as performance engineers, somewhat Renaissance people, because I may be a little bit biased here and not too objective, but I think performance testing is one of the most complex areas of QA where you need the most knowledge. You need to know about networking, development, instrumentation. You need to know infrastructure. You need to know even like CCNA stuff, many things. And to add on that, to be experts on Agile, understand CI/CD, understand databases, a full table scan that is like the deadliest thing that can happen. Here's some laughs over there. Probably you have experienced that. Know how to script, how to forge the communication from a real user into simulating with a script. All that is needed in a performance engineer. And as I said, nowadays it keeps increasing because we need to understand these many other things, not to mention the business. And if we sell cereal or toys, that things will flow differently. So another change that we need to take, we had in Mexico, Charro Negro, the black charro, the Lone Ranger, this hero that will come alone and save the day or make it worse, depending on the story that you were being told. But we need to evolve that into like the hero, as I was saying, the only one that can lift the sword. But we need to morph that into a mariachi band. I don't know if you have seen mariachi bands, but some key element is that at times, not only one of them sings. The one with the bass will come ahead and la, 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 and then goes back. And then another one comes up and starts singing with a guitar. Some other has, I don't know, maracas and all these things. Or all of them will start singing. We need to share that responsibility. We are a team. We are all working together. And we're responsible for this. We are a family bringing up a baby. The system that we're creating is our baby. And we are all responsible that our baby is not an ugly baby. We want them to look pretty. I know to mother's eyes, they are always beautiful, but it cannot be. And we all together need to be a little bit objective and be able to tell, like a mariachi band, we are a team on this. Don't stop that charro mentality that only one person is going to come and save. Everyone should share the responsibilities for performance, the scripting, being aware of those metrics, being aware that the system is slow. Everyone should know because it's important. Otherwise, the baby gets ugly. How we make this? As I was saying as well, we need to be as early as possible. Like our little doggy Chihuahua here, as soon as he wakes up, this is very Mexican probably, but we think of a huevito, some little eggs for breakfast with salsa and refried beans. This should be as he wakes up and just thinks of that. As soon as we start a project, no single line of code has been placed there. And we should start thinking into what we are going to do in terms of performance and QA, by the way. This doesn't apply only to performance. Are we gonna do, what language are we gonna program this? What database are we gonna use? What databases? Because we maybe, most probably will have to use more than one. What topology, what standards? When we create a pipeline, do we have to check in some performance continues, like the developer, who is the responsibility to execute the automations? Shall the automations be super slow, everything at the front end? Most probably not. Or should it be snappy, quick, that we can execute multiple at the same time? Everyone gets to the dessert, to the Dairy Queen without having to go to the other ones. And this is not only the very first day. This should happen every morning after we start sprint by sprint, on the sprint planning, on the retrospectives. When we start to create these little post-it tasks for our team members to move the job from pending, doing, to do completed, that jump should include performance, tasks, measurements, things that would say, does it take half a second or does it take 50 seconds? Should be under half a second. Sorry, you cannot move it. Make sure that when you check in this code, you, developer, created unit testing. That's another one that is super important. Who here is doing unit testing in their software, their organization? Okay. I wish I saw more hands. There were like 20%, which tells us a lot. That should be also a standard to be able to move those post-its in our Kanban boards. Have you integrated it into the pipeline? Have you done this task? Is it passing? How many database reads? All this has to be decided depending on the task and at every sprint. Okay, we have this requirement, this task. Okay, you need to measure this, measure that, and measure that. Probably not that one because you are not touching a database, so we don't care. All this has to happen continuously. And again, this is not only for performance, it's for all QA matters. Now, load testing little by little, increasing, getting there until finally we are ready to do a load test. So Never ever go straight to try to do load testing. Remember the example with the car? The same. Test first one process alone. When you have just created it, okay, little passes, behaves. 80% of the performance problems will be cleared out if you focus on one user. One user. I have had so many projects that I would arrive. Hey, you have to automate these 10 processes. Okay, let's get to it. Process one, like, it's really slow already. How has no one noticed this? Like, I was scandalized. That's why there's not that much hair. I kept pulling it. Like, how is this possible? How no one ever noticed? Like, this is, we release tomorrow. Like, have no words of blue screen. So after you test for one user, you can concurrently test for that single process. Then you can test for different processes together. And maybe eventually you will get to that bulk test that I was telling you before you make sure that everything is cleared out before you arrive to that point. Now, we should empower our developers. They are the ones preparing the software. They are the ones that know the calls, the requests. They should let them, they should be allowed to define and test and automate many of these processes, not only on performance. This applies also unit testing, many functional processes, pyramid of automation. They are the best ones that understand unit, the code, the calls, the requests, all those things. Whoever makes or breaks or changes something is the best person to quickly fix it. They shouldn't. So why it is a cook here? What we are doing right now, passing everything to the tester, would be like a chef. I'm preparing the soup, putting it together. I put it on a bowl. I put some crisp tortillas, put some cream on top, salsa on top. Here, test it. Needs salt. So I'm sending it back. It was already assembled. It was already put together. Shouldn't be him like testing, like have the indication from a chef before telling him, should be somewhat salty, somewhat here, should be this spicy, try this, and that, this perfect temperature. When you create it and when you give it to the waiter, the waitress, whoever is gonna take it to the person waiting and hungry, you already know that it's good. And you are not wasting the time like, hey, I packed it all completed. How is it? Back. That little, it may sound little, but we all lose a lot of time. Who has been here on the second Friday of a sprint going nuts, trying to keep up with automations, right? Because these things are being done waiting for us, we become again the bottleneck. And that's not efficient at all. We're losing time. And the best would be like here, the little Chihuahua testing the taco continuously. When we are releasing it, about to give it up, the developer automates, executes, and tests. Integrates it into the pipeline, and the pipeline automatically triggers all that, and all that is already running. That's the best recipe. And as I said, we should turn right to testing production. This is, I know it used to be a taboo, like, ooh, never, ever touch production. We need to touch it a lot. We have synthetics, as I mentioned. We have release techniques, blue, green, canaries, A/B, feature toggles, name it. The key is we have to prepare our release processes and our production environments to handle this. And with this, we can even do load testing with real people. And this is like a cliche that was like, are you going to put a bunch of people inside of a room clicking at the same time? With this, we can. And that's load testing. We don't need to do automation. We will get measurements of that little change that we released. What happens? Is it good? Oh, it's crashing. Feature toggle. We're good. Let's fix it again. Change the mindset. Go right as well. Now, how to? Here are some techniques quickly, because I'm noticing that I'm running short on time. As I said, on day -1, when we are just waking up, not day one, -1, before we start, define the tools, processes, principles, what are we going to use? Here I have some examples, my weapons of choice. As an APM, I put Dynatrace at times. All my code, all my automations, all my solution is in GitHub. I will save the logs, monitoring, metrics, all that in Prometheus. I will graph them with Grafana. I mean, I'm slightly biased there as well. I will use Jenkins as my pipeline and continuous integration engine, and K6 for the automations. Again, I represent some of those organizations and don't think that I'm so biased. This is a set of tools that you can choose interchangeably. Instead of GitHub, you can get Bitbucket, or Amazon has an equivalent. Instead of Grafana, you could get Kibana or Datadog dashboards, or I think there were other ANAs, something. Instead of Prometheus, you could get Elastic, you can get InfluxDB. So all of these pieces, or you can have both of them at the same time, because they should be able to coexist. This is another rule, no single tool to rule them all. Like no Lord of the Rings, Lord of the QA tools anymore. You need things from different tools. They should be open, easy to interconnect, and you should have a very good landscape of solutions. What to use: Travis if you don't like Jenkins, ADO, Gatling, Locust if you don't find surprisingly K6 appealing. I had to put a plug. But you got to change the ways. Instead of having the full dish of tacos, everything at the same time, trying to do one by one, little by little. You are just changing a little bite at a time. Don't eat the elephant at once. You'll be overwhelmed. The same in performance. Do different type of automations. Stop focusing on end-to-end and front-end automations, at least for performance and many other things, I think as well. They are heavy, they are slow. You need lots of resources, lots of machines. Avoid them as possible. It's not inevitable. There are times where there's no other way, or that is the way. Very few times. Don't go crazy. We all, I like to call it, is a Stockholm syndrome. We have suffered to it, but we ended up loving it too much, sadly, because there was no other way. So now we are now dealing in the service and microservice realm. We have to automate in that way. Stop focusing on putting lots of steps. And our automation should be integratable into the pipeline. Fast, snappy, shouldn't take that long. As I know in some organization, they tell me like, it's taking 10 minutes to complete the automation to execute. Like 10 minutes? That's years in a pipeline. That's so long. We should make them test. Okay, good, test, good, test, good. And in parallel, have as many as possible. They should be modular. We should be able to interchange them and play with them as much as we need. What about the browser? Anyone wants to think of the browser? It's very important also that we pay attention to web performance. The front end, now we are sending full operating systems into the browser of the users. Like anyone here killing the machine with Chrome tabs? That's why, because some of these applications are so heavy, so unperformant, and we don't pay attention to that. How are we going to simulate load? No. First clear one browser, one person, and then start to try to think on scaling up. But like the packaging at the end doesn't matter how the factory is doing, how overloaded. Your packaging here doesn't matter load. You can, if you want to know what happens with the browser when there's load in the backend, do some protocol, and then when you are doing your vault, open a browser and see what happens. You don't need an automation for that. You could implement also RUM, real user monitoring, tags inside of our HTTP elements. We need to assure that the web performance is good. That's another big fault that many organizations don't do well. So here's an example of how we can do it on every sprint. First, I mean, I relate with this puppy. I don't know if you have noticed. And as the performance chihuahua, to call it in a way, I'm going to call to the developers and tell them the SLOs are this, and that. So the developer will create the code and create a K6 script together with what has been just created and do the check-in. Okay, it's triggered automatically as it moves through the pipeline. It tests for one process, one user, one iteration. Passes, okay, can move further. That single process, more load, concurrent users, little, still fast, little load tests, tiny micro load tests. Good. Okay, let's test it with more processes, everything together in our universe of processes of the solution. Don't need to slam or bring down the system. Just let's test them all together. Good. We can keep moving. We can now, if it's needed, if it's Black Friday or these huge events that rarely happen, do that BALT test that I was telling you. And then the script ends up in production, continuously executing. And that's it. We detected if at any step it starts failing or we detect bad performance, right there and then we can stop it, put SLOs. These defined SLOs at the very beginning can move together with the script and integrate it in the pipeline. Oh, bad performance, you go back. And the check-in of that code or the pipeline stops and we're good. Now, when the code reaches production, we can leave it continuously running every minute, every 30 minutes, not a load test. It just pings once every minute, every 30 seconds. We can do it even every second if it's not that heavy. And as soon as something starts to deviate, starts to misbehave, because it has been running for days, we know that it takes more or less half a second. Oh, suddenly it's 1 second. Someone would say, no, it's twice the size. Could be a big problem. Take a look at it. Call the SRE, call the developers, call the people that you need, automatically trigger that alert. Or if it's something that you just released and starts misbehaving, send it as back as development. That automatically, continuously, and instantly will tell you when there are performance issues. And it wasn't like a huge effort, no big load testing, and hopefully you are performant forever and ever on your system. And yes, there's some load testing. Finally, at times it's needed, but extremely rare times. And by load testing, I'm referring to the BALTs. As I said, micro load tests here and there continuously, it's okay. Very well, you should do it. But those that we're gonna bring down the system, well, elastic environments, microservices spread all over the world. Good luck trying to figure out where is it getting stuck. Things do not work anymore like that. It's not the single monolith inside of its box that is contained. No. So this rarely happens. If we created all the devices that I told you, those scripts, those automations, those pipelines, that observability, that monitoring, you should not be needing this at all. Yes, it's still needed if you have a Black Friday, if you have a big time event that is coming. That is when you need it. Otherwise, just keep doing the small continuous loads and you'll be fine because you know that your system already performs in production. Adding a little change still performs. Good. I'm checking as this reaches production, still performs. You can reach production. Now in production, still performing. Good. Everyone happy. And with that, I want to thank you everyone for enduring this silly talk, this modern performance and the sillier examples. If we don't get enough time to cover all the questions, or you are a bit shy and you rather post them later, at SRPRF, Señor Performo, or Leandro Melendez. You can find me LinkedIn, Instagram, Twitter, Facebook. No TikTok, I'm not ready for that yet. So with that, thank you very much. And do we have time for Q&A? A little bit, right? So anyone curious? Yes, please.
Variation, variability, AWS, Lambda, serverless type approach versus like Azure.
Lambda is a different beast. I give you that. Tough to measure. But the key nowadays is, well, it depends as well. Are you using it in a single big bang release and for a big event? You may have to proceed in one way. But if it's continuous and you're continuously releasing, make sure that whatever arrives there is performant and that it stays that way. Detect it. And if you want to test increasing the load, increasing the users. But from my perspective, it's more important that you are aware how it is doing continuously. If it's well, probably your software is performant and the resources. beware on some of those because tend to be elastic, easy to go crazy. That's also a big recommendation. Don't do bulk if you have elastic environments, turn everything off. Otherwise, the build is going to be very interesting after the load test. But yeah, it depends a lot on what you are trying to get out of those. Yes?
Start based on. So that would be small changes. What if you starting a legacy system? And then you have tips for getting guidance and not to start at perfect.
So most legacy systems you can install an APM. That's kind of the easiest. Most of them will give you some information and detect what is happening with them. Sometimes you won't have access to the code, but if you have access to the code, open telemetry, instrument the code, make sure that you know what is happening on each one of those is the easiest. There are systems where you can't. There are systems when you'd better try to find a way to extract logs, put them in a system that you can analyze and follow up through. But yeah, legacy systems are hard not to crack, but big source of headaches, but it's doable. Most of them is doable. Most, if it's only 10 years old, I was thinking COBOL or something even further. Most of 10-year-old you'll be able to fix with an APM. An application performance monitor, but nowadays it's a manager, application performance manager. Such as your Dynatrace, AppDynamics, Datadog, New Relic are the most popular, expensive as well, but are really good. There are some open source ones, but those ones are really stable. One else?
Yeah.
There are multiple ways you can create your metrics or single data points with telemetry and instrumentation in your code. Send it to a logger or a metric storage, time-based databases. And a cool thing that you can also do from there is add tags so that you can generate traces and know where each user is going through. You can even generate test cases from there, analyze usage patterns if the user disconnected here, or like Facebook, like were you watching for too long? That lady probably suggests for you to become friends. Anyone? Most of the time, you should only be saving performance metrics. If you want to go deeper and do, as I said, user analysis, then you may have like credit card, social securities, and you should get together with them and say, hey, can we mask this or do the usual treatment? I think, yeah. One last one. I would say some of the recommendations that I'm giving are like a mutation of smoke testing or shakeouts, because as soon as you create the code, you are testing and validating how it is. So I think it covers somehow, not strictly, but you are covering some of those events. And as long as you have, again, good monitoring, good analysis of how everything is flowing through your pipeline, you'll be able to detect right away when there's a smoke, when something is not integrating, and some of those things. So tomato, unless you're very strict on the definition. But to me, I think you're covering some of those. Well, thank you very much.